This video discusses positioning and signal boosters. Consideration for the location of your system components and the effect this will have on the radio signals is extremely important. The signal will travel between units in a straight line and will degrade both with distance and, much more importantly, objects it has to pass through. A thermostat connects to the receiver via low power radio. This is not Wi-Fi. They connect to the internet via Wi-Fi, but the communication between the thermostats, sensors and receivers is not Wi-Fi. So the first question is, how do you check your radio signals? You can find this on the home page. You will find signals in the top right here. If you're on a mobile, you'd see them at the bottom of the page. And you can use the arrows here to switch between them. So we see the Wi-Fi is excellent. We can see the thermostat signal is fair, and the sensor signal is poor. Now, poor would certainly indicate a problem. Fair could be improved. You can also, if you have sensors, you might see these at the bottom of the page as well. So I'm just going to show you how the radio works. So at the moment, if we have a receiver and a thermostat and a sensor, the thermostat and the sensor, this would be a wireless thermostat rather than a wired thermostat, the thermostat and the sensor would communicate directly back to the receiver. They do not talk to each other. All messages are relayed via the receiver. So if we were to add a signal booster into the mix, the units would then potentially communicate via the signal booster, and the signal booster would communicate with the receiver. Now, if one device was closer to the receiver than the signal boost, closer to the receiver, say like there, then the thermostat may well communicate directly with the receiver rather than the signal booster. If it doesn't need to communicate via the signal booster, then it won't. If it's, but it always take into account the best path back to the receiver. So in a home, you will have other objects rather than just the distance. So if we look at a floor plan of a home, and then we can add some components. So let's add the receiver in this cupboard here, and the thermostat may want to be in the hallway. And to demonstrate a worst possible positioning, we'll put it underneath the stairs. So the reason this may cause problems is the path the signal takes. So the signal travels in a line of sight. So here you can see, let's say if a thermostat was positioned here, then it's probably okay. The signal would pass through this one wall here, this wall here, and a bit of distance, probably about 10-15 meters. Should be absolutely fine. However, if the thermostat was located in the hallway, I'm just going to move this to emphasize the problem. You can see now the signal is traveling through this wall, and then it's kind of traversing along this wall. So effectively what we've done is created a wall which is potentially 5 meters long, or 5 meters thick, which is going to be a real struggle for the thermostat if it's even possible to do it at all. It would probably just not work. So if you're in this situation, the ideal solution would be just to put the thermostat on that wall, and you can see the signal as it goes through a lot easier. It's going through 2 walls and nothing else. Whereas here, the wall is essentially 5 meters thick, and it's not really going to help. Now, if you have to do this, if there's no choice, this would be when the signal booster would come into play, because you can relay the messages around. So let's add a signal booster into the mix, and now the units would go via the signal booster, assuming it thinks it's stronger. So straight away now, that 5 meter thick wall has gone. We've got one wall there, possibly going through the open doorways there, but again, it might hit that wall, so possibly 3 walls, and that one might hit that wall. So it's okay. But again, you might find that the signal booster was in that room. That's now going through 1 wall, and that's going through 2. But you can see there's various other locations. I mean, even moving it extremely far away into the kitchen. Okay. Bad example, probably the hallway. The path of a signal is a lot cleaner. There's none of these really super thick walls to go through. Same would apply if a thermostat was upstairs. Then you would have the ceiling to go through. So I haven't actually got a second floor here, but let's say that was upstairs. Then the signal booster, if you placed it at the bottom of the stairs, you've got a nice clean path for the signal to go through to here, and then the signal booster straight up the stairs to the thermostat, or up through the ceiling to the thermostat, which should be a lot easier path for it to go down.